Hi, welcome to this video. Once again, I have lots of parts on my table, and once again I'm going to build a 1980s retro computer, and this time it will be the COMIX-35, which is a replica of the COM-X-35 from 1983. Now, I must admit that until recently I had not even heard of this computer, because it wasn't marketed in my part of Europe and it wasn't very popular worldwide, although it had some moderate success in the Netherlands. Now, what's most interesting about this computer is its CPU. It's not the usual Z80 or 6502 that we would expect. Instead, it's an RCA 1802. This CPU was hardly used in any home devices. The most notable use was in the RCA Studio 2, a short-lived video game console from 1977. This is the main board, which has been designed by TubeTime in 2020, and he also did a few modifications. For example, it now runs on 5 volts power, and it provides composite video output instead of RF output. So I ordered 5 of these boards in China. This board is much larger than what I had previously built, which makes it a little more expensive, but the price was still okay, considering that it will be having a mechanical keyboard. I've decided not to order the Sherry MX switches and keycaps for now, but instead I'll first try to get everything working without a keyboard, and if that should be successful, then I'll order the keyboard parts. Here at the top left corner of the board goes this power jack for the 5 volts power supply, and I would have to build some adapter cable for connecting a 5 volts mobile phone charger, which is something that I'm not really keen to do. So I once again had a crazy idea. I designed this tiny little adapter board, which exactly fits here, and I will solder it to the board with pin headers, and on top of it I will solder a micro USB breakout board, and so I will be able to directly connect a mobile phone charger to this computer. And if one day I should decide that I don't like this anymore, then I can always remove these parts and solder the power jack to the board as it was initially designed. So, enough talking, I'm ready to start soldering, and now let's get right into it. Okay, here it is. After 2 Sunday afternoons of soldering, everything's done, apart from the keyboard, which I'll do later. Here's a power switch, here's a tape loading indicator LED, here's the video jack. 2 parts are marked as do not install in the bill of materials, and these are this R24 resistor and this crystal Y3. And just look at this tower that I've made for the micro USB power supply. Isn't that beautiful? Before we connect the power to the board, let's make a few checks now. I've set my multimeter to continuity mode. Let's take a look at this micro USB breakout board. Here on these 5 pins we have access to the 5 lines of this micro USB jack. And we are only using 2 of them, namely ground and V-bus for the 5 volts. These 2 pins, ground and 5 volt, they must never be connected, because otherwise you would have a short between ground and the 5 volts rail. So let's check that. Okay, it does not beep, so that's fine. We will now hold 1 probe to the ground pin, and then we'll touch the outside of this video jack. And here, as expected, it's beeping, because it's properly connected to ground. Now let's take a look at these IC sockets. Let us check whether they will get the power that they will need to operate. All these ICs, except for this small one, have the usual pin configuration. If the notch is here on the left, then ground is here on the bottom right pin, and 5 volts is on the top left. Now let's check whether ground is properly connected. So we'll first touch ground with one probe and then the bottom right pin of each socket, and we see that these are all properly connected. So that's fine. And let's try the same with the 5 volts. And for this we have to turn on the switch because this one disconnects the 5 volts line. So let's touch the 5 volts pin and then the top left pin. And this is fine as well. And I've checked all the remaining ICs. And we can now even check whether this switch is working. So we'll first touch 5 volts here and the top left pin. Now it's not beeping. And when I switch it on, it starts to beep. And when I switch it off, it goes off again. So this looks fine. I've now connected a mobile phone charger to the board. And I've set my multimeter to voltage measurement. And now we'll check whether these ICs have the correct voltage. For this we will have to turn this switch on. And look at this, the power LED has gone on. We will now check this one. And this is roughly 5 volts. And the same here. And here. Okay, and this is no big surprise now because we have previously checked that the connections are all there. And I've checked all the remaining ICs and they are all fine. So this test has been successful as well. Now we have to write the ROM image to the EPROM, which is part number U15. The COMIX ROM image is 16K in size. But the neat thing about this COMIX-35 replica is that it's using a 32K EPROM. And we can put 2 ROM images on it. And we can use Jumper JP5 to choose which of the 2 ROMs we would like to use. I've decided to put the latest original COMIX ROM onto the EPROM, which is version 1.3. And then there is this COMIX High-Speed Direct Connect project, which allows high-speed loading of software. And this requires a modified ROM, which we will put on the EPROM as well. There are several ways to do this. I think that in the program software you can select the starting address for writing data, and with that you can write the first file to the beginning of the EPROM and the second one to the upper half. However, I prefer doing this by concatenating the 2 files using the copy command, and then writing this single 32K file to the EPROM. Let me show you how to do this. So here are the 2 files, and I will first rename them so that I don't need to type in these long names. I'll name them just 1 and 2. Okay, 1 is the original ROM and 2 is the modified ROM. And now I'm going to open the command prompt, and I'll change into the directory where my files are located. Okay, here they are, and now I'll type copy/b. This tells the copy command that we are dealing with binary files instead of text files. Then 1.bin plus 2.bin, and then the desired name of the output file, and I'll name this final.bin. Okay, and now let's check the result. And here we have the concatenated ROM file, which is 32K in size. I've now connected the programmer to the USB port of my PC, and I've inserted the EPROM, and I'll now start the programmer software. And first we need to select the type of EPROM we are using. In my case it's an Atmel AT28C256. It's this first one. Now to make sure that our programmer can deal with this type of EPROM, we can make a read check. We can try to read what's on the EPROM. Okay, and this has been successful, and we see that it's all blank. So now we have to load the file that we just created into the buffer, and it's here. Okay, now it's in the buffer. Here we see copyright 1983. And now we will write this to the EPROM. We do this by clicking proc and program. Okay, this takes some time. Okay, and it's been successful. And now comes my favorite part. I'll now populate the IC sockets. And now the moment of truth. I will now power it up for the first time. I've set up everything. Here's a mobile phone charger connected to the board. Here's a little speaker, so in case that we don't get an image, we should hopefully hear the startup sound. Here's the video cable connected to this TV, which is on and set to this video input. And now let's keep our fingers crossed. I'll now power it up and let's see what happens. Okay. We are getting some image. It's not quite right, but at least it's something. Let's now press reset. Okay. Okay, the reset button is working, so that's a good sign. So it is alive. The heart is beating, otherwise it wouldn't be reacting to this reset button. But the image is not quite right. And one thing that's worrying me is that we don't hear the startup sound when I press reset. Okay, well, at least that's something. I'll have to investigate. Okay, off camera, I started tweaking these potentiometers to see what happens. And let's see what happens when I move this one, which is labeled sync level. And look at that! We have an image. Okay, because the image was obviously out of sync. So that's fantastic. One thing that's still worrying me, we are still not hearing the startup sound. In the meantime, I've been able to track down the problem with the missing sound. With my limited knowledge of electronics, I thought that maybe there could be some missing connection, and I suspected the problem to be here in the upper left area of the board, near the speaker connector. I first thought that maybe I had put in one of these electrolytic capacitors the wrong way, but they are all fine. So I looked at this schematic, and I checked the connections on the upper side of the board, and then I found out that this connection here just wasn't there. And then I remembered that I had first soldered this U17 socket the wrong way with the notch facing the wrong direction. So I took it out again, and when I resoldered it, I had lots of trouble soldering this particular pin here. And now I know what had happened, because when I desoldered it, I must have damaged and entirely removed the soldering pad. So finally the solder ended up on the pin only, but nowhere else. So I tried connecting these two pins with a short piece of cable, and I could immediately hear a faint humming sound coming out of the speaker. So I knew that this would fix it. So all I needed to do was to put in a short piece of cable between these two pins to re-establish the connection. And when we power it up now, we can hear the startup sound. A few weeks have passed now, and in the meantime I have ordered and received the key switches and the keycaps. Let's look at the switches first. These are 5-pin switches, and the number 5 means that the plastic pins count as well. We have 3 plastic pins which hold the switch in position, and we have 2 contact pins, and these contact pins are shorted when you press the key. So all you need to do is you clip them all in, and then you solder the 2 contact pins on the underside of each key, and then you have a complete keyboard where you only need to put the keycaps on. And I also ordered this spacebar leveling kit. I found this one at Marcel, and the plastic parts are fine. The only problem is that this wire bar is very short. I don't really understand what this is for. Anyway, so I also ordered this complete set from AliExpress, which has leveling sets for different lengths, and the longest one has the wire bar with the length that we need, so we'll use this one. Interestingly, these plastic parts do not have the clips on the bottom, so I think they are supposed to be glued to the board. Anyway, we'll use this bar in combination with the plastic parts from the mouse set. And now let's look at the keycaps. I had to order the full set with 125 keys because I needed these cursor keys and a few extra ones like the single plus key. And this is the same set that has been used in every other of the 4 or 5 COMIX-35 builds that I've seen on the net. And there's a reason for this. These are DSA profile keycaps, and there are not many of them to choose from. Now, what does the term profile mean? There are keyboards with different keycap profiles out there, and the most common one seems to be the schlae profile. And on such a keyboard, the key rows towards the backside of the keyboard are not flat, but they are tilted towards you for more ergonomic writing. There are various beautiful and inexpensive key sets available, but the problem is that we can't use them because we cannot exchange the keys from one row with the keys from another. And since we have a non-standard keyboard layout on the COM-X, we'll have to pick keys from each and every row to get a complete keyboard. So for making such a retro computer keyboard, the best option is to use a DSA profile keyboard, where the surface is entirely flat on each key of the set. An alternative would be the XDA profile, which is very similar to DSA, so you can try that one as well if you should find a set that would have all the required keys. Another thing that I've noticed is that a German language keyboard has better matching keys for the COMIX computer than an English one, so I ordered this add-on set as well, which gives you the specific keys for a German keyboard layout. This one has the Ö and Ä and Ü keys, so when you see these you will know that you have a German layout. Let's now compare the number keys on the original COMIX computer with the keys on these two sets. And let's start with the 2 key. On the COMIX it has the double quotation mark on top of it, and here on the English set we have the @ character, while on the German layout we have the double quotation mark that we need. Okay, the 3 key is better on the English layout, and it goes on with the 4 and 5 keys, which are identical to the COMIX layout. And from the 6 key it gets better on the German set again. So the 6 key has the amp sign, which is here, and the 7 key has the slash, which matches as well. And it goes on with the 8 and 9 keys with the brackets. And the 0 key on the COMIX has the equation sign on top, just like on the German keyboard layout. And the same here at the bottom. Okay, we have the comma with the semicolon and the dot with the colon, and this one matches as well. So we still won't get all the keys right, but we will have fewer stickers to put on the remaining non-matching keys. The only problem is that it gets quite expensive when you get this extra set as well, because this full set was quite expensive already. But if you should incidentally find a complete DSA or XDA profile German key set in the future, then go for it. And now let's put in these switches. So all the switches are in now, and the good thing is that they won't fall out when we turn the board to the other side. Okay, now we need to solder these two pins on each of these switches. So let's put in the keycaps now, and I'll start at the top left with this RT key, and like the others who built this computer before, I'll use this key, whatever this is. So the last thing to do is the assembly of the spacebar stabilizer, and I've put the spacebar upside down here so you can see that this goes here, and we will put two of these tabs here on the outside. And these plastic tabs come in two parts, and if the inner part can move all the way down, then it's fine, but if you put it the other way around, it cannot move down. So you need to turn it around, and if it can move freely, then it's fine. So I've prepared one of these packs here for assembly, and mind the orientation, it goes in like this. So if we now move this tab, the other one is moving as well. So now we can finally put the spacebar keycap on it. And here we have our fully assembled COMIX-35 computer. I've connected it to this LCD television because it's easier to shoot a video on that. So let's turn it on. And let's check the keyboard first. So the keyboard is working. And now let's type in a little basic program. So this is working as it should. I found out that Control Escape breaks the execution of a basic program. I would have loved to show you a game running on my newly built computer, but the problem is I can't load anything, and I'm not sure where the problem is. I don't think that I did something wrong during the building process. I think it should rather be a problem with the audio signal that's coming from my notebook computer. It's either too strong or too weak, or something else is wrong with it. I've also tried feeding the audio output from the computer to my stereo, and from there over the headphone output to the comics, so that the signal gets stronger, but that didn't help. TubeTime wrote that it is tricky to get it working because of the way they had designed this tape input part of the hardware. I'm now getting either a loading error, as you can see here, or nothing happens at the end of the loading process. But I think the loading error is the better option, because you see that there is indeed some loading activity. With this potentiometer here, you can adjust the tape input bias. And this LED shows the loading activity. When you're listening to this loading sound, you can hear either a long constant beep, and this one indicates that data will soon be coming in the audio stream, and then you hear these individual beeps, and these contain the data. So as far as I understand it, you need to adjust it that way, that during the long beep, the LED must be constantly on, and during the data beeps it must be flickering. When you've set it too low, the LED will be constantly off, and when you set it too high, it will be permanently on. So you have to find the right position in the middle. So I'm now trying to adjust it. So I think that should be it, but I've noticed that the area where the bias is right is very narrow, and I've compared it to the YouTube video of the Clueless Engineer, and I've noticed that for him this area seems to be a little wider, but I don't know where the difference is. It could be, as I've said, some issue with the audio signal from the computer, and I've really tried it many times with different volume and bias settings, but I couldn't get anything to load. So I have given it up for now, trying to load anything over the audio input, and instead I have ordered and received the parts for the high-speed loading adapter. And this consists of only a few parts: this edge connector, then the board with only 2 resistors, 2 diodes and angle pin headers, and that's it. This edge connector was a bit expensive. I could only find it at DigiKey. You can find such connectors with 44 pins elsewhere, but the problem is the spacing between these 2 pin rows, which is 3.96 millimeters. And this is a bit uncommon. So this one was expensive, but just look at it. It looks beautiful, and it even matches the color of my board. So let's build that, and I hope that I will finally be able to load software on my new computer. And here is the expansion port with the high-speed loading card inserted. For data transfer we'll be using such a USB to TTL cable that I've acquired. There are many of these cables available out there, but be aware that there are various different pinouts for this 6-pin connector. So make sure that you get a cable with the correct pinout, and make sure that your adapter is made for 5 volts. I took the one that the makers of this adapter have recommended. So the next steps are, I will first install the driver for this USB adapter, and I'll download the terminal software that we will be using for file transfer. I've now set this jumper JP5 to the second ROM, which I have written to the upper half of the EPROM, and this is the modified high-speed loading ROM. And when we now start the computer, you'll notice that the startup screen looks a little different than before. This ROM has been patched so that when you tap pload, it will not be listening to the tape input port, but instead it will be waiting for data to arrive through the expansion port. So in the meantime, I've tried it off camera, and I'm glad to tell you that it's working, and I'll now show you how to use it. It's actually very easy to use, and loading a program only takes a few seconds now. First you connect the cable between the PC and the comics. Mind the orientation of this cable. The black wire, which is ground, must be on the left. So we start TerraTerm. It is this tterm pro exe file that we need to start. And here on this connection screen we need to switch to serial. And if the driver has been installed correctly and the USB device is plugged in, then we should see this USB serial port device, which is COM9 for me. So I'll select this one and we click OK. And now in the comics you type pload, and now it is waiting for data to arrive on the expansion port. Back in the terminal program you select send file, and you can now choose a file with the COMX extension, and I'll pick this boulder-clone. And you can use all these default settings, but you must activate this binary checkbox. Fortunately, you have to do this every time you transfer a file. The program does not remember this setting. At least I haven't found out yet how to make this the default setting. And soon a progress window will appear. And this takes only about 30 seconds to transfer this file, which is nothing compared to the many minutes you would be waiting for the program to be loaded from tape. So let's wait a few more seconds. We'll soon be ready. And after that, you will notice on the comics that loading is finished when it says ready. And then you type run. And here we have the game running. Let's now take a look at a few other games. This is Maze Race, and this is the classic head-on game, or Dodgem as it was called on the Atari console. And here you need to avoid colliding with the computer car, but it will get you anyway. And this is Cross Chase. This is a cross-platform game running on the incredible number of 200 different systems, and the COMX is one of them. So, Fabrizio, if you're watching, this is your game running on the real hardware. And this is Look Before You Leap. Here you have to reach the other side of the screen without hitting one of these lifts that are moving up and down. And every time you reach the other side you can move up by one floor. Quite a simple game, but it's addictive. And this is Gate Master. This game has obviously been inspired by the game Ladybug. And this is called Dragon, and this is obviously a clone of the game Centipede. And this is Kilowatt, and this is a remake of the Commodore 64 game, but it's a lot more difficult here. And finally, this is Get Your Gadget, and I think this is maybe the best game of all, together with Boulder Dash. And here you're flying a helicopter through caves, and you need to pick up various items. So I think we can call this a successful ending to the project. Thanks for watching, and until next time, goodbye.